Hello friends, good morning. Myself Dr. M.H. Chennaiya, and in today's video we will learn about the projection of a square pyramid which is resting on one of the triangular faces on HP. So friends, they have given the dimensions of this base. It says the base is 30 mm, that is every side in the base measures 30 mm, and the height of the axis is 60 millimeter. Axis is the distance measured from the vertex to the center of the base. This we call it as O, and this is O1. A vertical distance of this solid is called the axis or height of the axis. So friends, let us see what the problem in store for today's session. A square pyramid of side of base 30 mm and axis 60 mm rests on HP on one of its triangular faces. Friends, analysis of the question given is very important. First of all, you should see what is the type of the pyramid given. Is it triangular, square, rectangular, or pentagonal, and so on. Here it is a square pyramid. So immediately you should get in your mind that a square pyramid has got a square base. It has got four lateral surfaces, and all these surfaces are isosceles triangles. That means they will have a base equal to the given length of the side of base, and height is equal to the height of the object. So a pentagon will have five lateral surfaces, a hexagon will have six, and so on. And next comes, how is the object resting? So he says it is resting on HP. So it is resting on HP. On what? On one of the triangular faces. So you should get in your mind. So it has to rest on triangular face on HP. So before that, you have to make it to rest on HP. Say my palm is the HP. Such that one of the base edges, the shorter edge of the pyramid or the base edge, is vertical, and that is normal to VP. So friends, I am going to write down the top view of the pyramid, which is going to be a square of the given side. So friends, this has got a side of 30 mm. So I will just mark it as 30 or 30 SQ you can mark. SQ indicating the square. So this is A, comma B, this corner is C, and this is D. This is how the base looks in the top. And here, let us say this AB is perpendicular to VP. Very obviously, CD is also perpendicular. And if you join the diagonals of this, that is AC and BD, they meet at a common point. This point is called O, the vertex of the solid. And friends, corresponding to this, let us obtain the front view of this. So very obviously, when you place like this and see friends, you'll be able to get one triangle, an isosceles triangle in the front view. How to obtain? Friends, we'll project these lines, points from here, A, B, C and D, they meet here on the XY line. I call this point as A dash B dash, and this is C dash D dash, and this line A dash B dash C dash D dash on XY represents the base of the pyramid in the front view. Next we will locate the height, mark the height. So from this point O, write a vertical line representing the axis. The height is given to be 60 mm. So I am going to mark the height of 60 millimeter, which is perpendicular to this HP. This will call it as O dash, and the bottom center as O1 dash. Here you get O comma O1. Friends, after getting the height or the vertex of the solid, let us join the vertex to all the corners. So I am going to join O dash to A dash, O dash to B dash, O dash to C dash, O dash to D dash, and this triangle O dash, A dash, B dash, C dash, D dash represent the front view of the solid when it is resting on HP with one or the base edges normal to VP. Here this AB is normal to VP, and we have got this front view, a triangle. Friend, what does it say in the question? It has to rest on one of its triangular faces. I told you, it has got four triangular faces on its lateral surface. And if you observe the front view for the initial position, the last line, O dash, C dash, D dash, represent a triangular surface. How? Because there are 3 points. If there are 4 points, it represents a rectangular surface or square surface. If you have got 5 points on this, it represents a pentagonal surface. So friends, here this line O dash, C dash, D dash is one of the triangular face because it has got 3 points. Now it is at an angle to HP, but he says it has to be on HP. In other words, whatever this triangle you have got here or this face, this is a triangular face, this is O dash, C dash, D dash, it has to be on HP. So I am going to make it to rest on the HP. So friends, when you make it to rest like this, it is resting on HP on one of the triangular faces. That is OCD. So friends, what I do, I just draw a triangle here, and this triangle, suppose this figure is number 1, this is figure number 2, and friends, here this figure number 1 and 2 are the same. So you are redrawing the front view of the initial position here. How to construct that also I will tell you. Friend, this is going to be O dash, and this is our C dash, D dash, C dash, D dash. Obviously this is A dash, B dash. So how to construct this, friend? You know this O dash, C dash, D dash. Take some point CD, mark that distance on XY. So this OCD will be this surface. And similarly, this line is OAB. It will have the same length as this. So you can draw an arc taking O dash as center, this length as radius and arc. Similarly, taking the base, that is 30 millimeter radius, another arc you draw. The point where those two intersect will give you the edge A dash, B dash. Friends, I will write down here that OCD is on HP, that is the triangular face is on HP as per the question given. So once you have got this front view, let us obtain the corresponding top view for this front view. Here friends, as usual, we are seeing the object from the top here, and you are going to locate all these 4 corners of the base and the vertex O dash. So let us take one by one. Let me start with point A. So write a vertical line from A horizontal line from here. These two intersect at this point. We will call it as A dash. This is A dash. A. Similarly, vertical line from B, a horizontal line from B. The point where these two intersect is our point B. So you have got A and B. Next comes C and D. Vertical from C, horizontal from C. The point of intersection is here. That point is C. And finally, this point is D. Friends, you have got all the 4 corners of the solid in the top view. Friends, you should remember, whenever any of the pyramids, whether it is a triangular pyramid, a square, or rectangular pyramid, whatever may be the pyramid, whenever it is resting on HP, on one of its triangular faces, that is a triangular face like this on HP, or one of the slant edges or the longer edge on HP, in such cases, the complete base of the solid is visible in the top view. In other words, the base has got 4 points A, B, C, D. So they are completely visible. Means I have to join all these by dark line. So if it is a pentagon, you will have 5 points. Hexagon, you will have 6 and so on. Let me also locate this O1 dash, the center of the base that comes exactly here in the center of this. So I will just mark it here. This point is O1. O1 is the center of the base and this is the base. Friends, let us obtain vertex. Draw a vertical line from there, from the vertex, a horizontal line from here. The point where those two intersect is the point O. So I have got the base. I have to join the vertex to A, B, C and D. Let's see what happens now. Friend, always the borders are to be shown by dark line or visible line. So I am going to join O to A. Then O to B I am going to join. Next, on the same lines, I have to join O to C. Friends, when you are joining O to C, this line OC is intersecting this AB. Friends, we know very well, whenever two lines intersect, if one of them is known to be a full line or a visible line, the intersecting line should be a dotted line. That is to say, we know very well AB is a full line, visible line. And if I am writing this OC, it is intersecting here and hence this has to be a dotted line, an invisible line. On the same lines, OD also intersecting AB and this again has to be a invisible line or a dotted line. Friends, we have got this O1. O1 is the axis of the solid and you can see here, friend, the object is resting on triangular face OCD and here he says in the question with the shorter edge of that face parallel to VP and nearer to A. Friends, here it is resting on triangular face like this. The shorter edge of the base are A, B, C, D. And for this particular triangular face OCD, CD is the shorter edge which is perpendicular to VP. So this is perpendicular to VP. But he says it has to be parallel to VP. The edge of that is to be parallel to VP and nearer to A. Friends, I will call this figure as figure number 3 and I am going to redraw this figure 3, the top view, such that the edge CD, which is normal here, becomes parallel to VP, parallel to XY. It has to be drawn to the same dimension and obtain the corresponding front view. Friends, it is very simple. Let me construct this rectangle first, anywhere below the XY line at any convenient distance. So this rectangle, whatever I have constructed, is this rectangle ABCD. CD is at the end. So this is CD. This will be obviously AB. So A, B, C, D. This should be in order, either clockwise or anti-clockwise. The center of that is O1. And from there you can extend this line. You can know the length of this. Get the point O. So the last line is CD. CD, AB is in the center. So I will write a vertical line from there and get this point. So this figure number 3 and figure number 4 are the same. Only thing is here CD is made parallel to XY as parallel to VP and otherwise they have got all the same dimension. Friend, this has to be a dotted line because we are copying down the previous figure 3 and redrawn here. So friend, this figure with CD parallel to VP will give you the final top view and I have to obtain finally the front view corresponding to this top view. How to obtain, friends? As usual, start with this point A. So write a vertical line from a horizontal line from here. The point where those two intersect is our point A dash. Similarly, B, horizontal line from B dash, vertical line from this point B. The point where those two intersect is the point B dash. So we got A dash, B dash on this. Likewise, friend, C and D are on the XY. This will give you the point C dash, and this will give you the point D dash. So I got all the four corners. And friends, let us obtain O. O is the vertex. So I should get O dash here. Write a horizontal line from O dash, a vertical line from here. The point of intersection will give you the point O dash. That is the vertex. O dash I will get. Friends, we have got the O dash, the vertex, and all the other four corners of the object are obtained. And friends, here let me join all these by straight lines. So A dash, B dash, B dash, D dash, C dash, D dash, A dash, D dash. These are the four corners of the base of the solid. And friends, I have to join this vertex to all the corners. That is from O dash to A dash by straight line, from O dash to B dash, another straight line, O dash to C dash, O dash to D dash. Friends, this, if you mark the center of this, you will get the point so called O1 dash, the center of the base of that solid, and this is O dash. Friends, this figure will represent the final front view of the solid. And to verify whether the solution we have got for this question is right or wrong, let us have a small check. Friend, you can see here the pyramid is resting on one of the triangular faces. The triangular face is OCD, that is on HP, and the shorter edge of that is the CD, that CD is perpendicular. But in the question it says it has to be parallel to VP. So I have drawn this figure here by rotating through 90 degree so that CD becomes horizontal and obtain the front view. And here, friends, the line C dash, O dash, D dash, C dash, O dash, D dash is this line. This line is a triangular face. Hence, I can conclude the triangular face is on HP, and hence it is satisfying all the requirements of the question, and this will give you the complete correct solution for the problem. Friends, I hope you're happy with the presentation I have made. If happy, share the information with all your friends and have a nice day. Thank you very much.